guys, what's up? It's your boy Trix. Today is going to be another coding video, so let me just get the dashboard up. There we are. And then we're going to be doing some more Rust exercises. So we're going to be doing Collatz Conjecture, Diffie Hellman, and series. So let's get right into the video. Cool. So Collatz Conjecture. Collatz Conjecture or 3x plus 1 problem can be summarized as follows. Take any positive integer n. If n is even, divide n by 2 to get n divided by 2. If n is odd, multiply n by 3 and add 1 to get 3n plus 1. Repeat the process independently. The conjecture states that no matter which number you start with, you always eventually reach 1. But sometimes the number grows significantly before it reaches 1. This can lead to an integer overflow. It makes the algorithm unsolvable within the range of a number in U64. Given the number and return the number of steps required to reach 1. Okay. So let not count 0, right? Then we do if n mod 2 was equal to 0, if n mod 2 equals 0, do count plus equals 1, and then do Collatz bracket n over 2. Otherwise, so if it's not even, you want to sorry, I wrote it in Python because that's how you would write it in Python. This is how you write it in Rust or Java. I don't know what's wrong with me. So if it's not even, then you just want to do count equals count plus 1. Forgotten that equals doesn't exist. And then you do Collatz bracket 3 times n plus 1. I don't need to add that there. Oh. I'm not sure now because that should work. Unless you can't pass expressions to a function. Okay, let's have a look at the solution. For I in 0 to whatever. Okay, so it takes an integer and just measures it up. So if n is 0, break. If n is 1, return some I. Okay, I'm not sure what some I is doing. Even, if even mod 2, so this just stores even, so the number n as even. If even, so if the number mod 2 is 0, then the original number divided by equals 2, so just make the original number equal to the original number divided by 2, and then for all other numbers, check if it's a multiple of 3, and if it is, add 1. Oh, this just checks if the number exists and multiplies it by 3 and then adds 1 to it. Okay, and then otherwise it just returns none if it doesn't satisfy this. What's wrong with this? It's made this mutt. So that this is mutable because you're actually changing the value of n. Oh, if my voice sounds a bit quiet, it's because my brother and my mum are currently sleeping. So I'm doing this recording like kinda early because I'm gonna go out today. But yeah, I'm trying to do this early. Diffie Hellman key exchange. Alice and Bob use Diffie Hellman key exchange to share secrets. They start prime numbers, pick private keys, generate and share public keys, and then generate and share secret key. Task. The test program supplies prime numbers P and G. Okay. Alice picks a private key A greater than 1 and less than P. Both do the same to pick a private key B. Alice calculates private key and none. G power mode. Do I even have a algorithm? Yeah. Okay, so that's the same. Oh, this requires non-big int. That requires rand. This one looks normal. Okay, so private key is just P divided by 2. Pick a private key greater than 1 and less than something. Okay. 2 divided by 2. I don't know why P divided by 2 works. Okay, and then public key. I don't know what the hell the logic is. Mod add, mod proc, mod pal, private key. That's not okay. Okay, so this one's probably like the easiest one, I'm assuming. This one, I mean. Okay, so this is just picking them big int. If I don't understand this code, I'm just not going to submit it. P less than 3 panic else 2 G power mod A comment B. If B underscore power mod A comment B. Wait, B underscore power. B underscore pub. Power mod A comment B. Oh, so that's the B public key. Then you have power mod. And then power mod big uint from self. Let's answer is base mod power, big uint from power, and big uint from modulus because you're actually adding in the power and the modulus. And then answer it to use 64 digits next unwrap. Okay, this makes sense-ish to me, basically. Okay, let me copy all this. Because it's a lot easier to copy when you're to implement something when you copy it over and explain it. Okay, cool. So this just brings in the big uint library from use big int because of, where was it? Then where's the overflow? Nah, it doesn't show it. Ah, here we are. The number could overflow. So basically, all you're doing is, in the first function, you're checking what the value of P is. because you need to have p greater than 1. And basically, I'm assuming that p is supposed to be a randomly generated number. And in this scenario, all we're doing is just making sure that 2 is returned, as the tests only require 2, I'm assuming, for the private key. Where is it? Private key, bracket I from 5 lens, okay. Expected. Yeah, it's just always expecting the private key to be 2. I don't know why that's so dumb. Okay, hang on, let me just test if this works. Failed. This may cause problems. What is it? Non-vacant equivalent version does not match your available. Oh, I'll just grab this then. Should work. Yeah. That's so stupid. Anyway, all this is checking is that p is greater than 1, and this isn't how it's supposed to be. It's just supposed to be a random integer from p until a value, but because the test's in this, and you require, I'm guessing, a even digit or 2 as the actual private key, you don't need to specify like the actual logic for it, and that's stupid. Here, public key is just saying, public key is just literally this. Look, G A mod pal. So all you're doing is you're taking G pal mod is just saying take first do the power and then do modulus of p. So same thing here. So p bob pal mod power. So raise p dot pub to the power of a and then modulus it by p. And then power modulus is just creating a class, abstract class that has a function inside of it that you're able to utilize. So this makes like an abstract class. This is an abstract class, and this is an unimplemented abstract function, if that makes sense. So you have power mod, which has take self, a power, and modulus, and return self. So inside this implementation, this is just like implementing power mod. But most of the time when you use something like trait, you'd actually use it for other... When you want to have multiple classes that use the same abstract class. So this would make this code more extensible because you could utilize this class in other classes. It's just, this might have been easier to do if you just done it as a struct, but it still works. But structs don't have functions. Most structs don't have functions, and you can't like do this inside of a struct. So I'm guessing that's why they've done it as a function inside of an abstract class, so that you can actually define all the parameters and the return type. But okay. And all this is doing is just implementing the abstract class and then saying, oh, we want to actually add a function definition that would be executed from this abstract class. And all you're doing is creating the base, which is a big unsigned integer from self being the value that was passed to power mod. So because you're calling power mod on a variable, self would be that variable. So you're making that the base. Then the answer is just that base number. So p pub g, or where is it? No, just p pub or g. And you're just saying mod pal, which is inside the big uint. I'm guessing it's inside the big uint library, or it might be in the math library. And all this is doing is making power, is typecasting power to a big uint and typecasting modulus to a big uint, and making sure that the power and modulus are affecting base. And all it's doing is returning the answer as a unsigned 64-bit digit, retrieving its result. Okay. Now series Let me just control F to go to easy series. Given a string of digits, I'll put all the contiguous substrings of length n in that given string in order they appeared. For example, the string 49142 has the following 3-digit series: 491914142. The following 4-digit series: 49149142. And if you're asked for a 6-digit series or a 5-digit series, you deserve whatever you get. So this is just saying that whenever, so basically because you have 49142, you'd have 491914 and then 142. And then if you have a 6-digit series but you only want to get 5 digits, so in here, if you have 4914 and you have a 2-digit series, it'll be 4991 and then 14. This one, if you have a 3-digit series, it'll be 914 and then 142. If you have a 6-digit series from a 5-digit string, a 6-digit series from a 5-digit string. So say for example, it's like a 5-digit series from this 4-digit string. Nothing would be returned. It would just return a panic error or something, I'm assuming. So let me just see if the logic makes sense. Okay, so if I look at this, all this is doing is it's iterating from 0 to digits to the length of the digits plus 1 minus that length. And then you're mapping for each integer in the digits string. You want to retrieve each value from the string and turn it to a string and then collect it. I don't know why they would do underscores, because I think it's making it private, but that shouldn't be necessary. Yeah, it's not necessary to make it private. But all it's doing is iterating from 0 to the digits to the length of the digits in the digit string. And all it's doing is creating multiple string arrays with a substring of the digit. So it's doing from one integer to the length of the string that you want to get. So this just makes a substring, and then you're saying, oh, you want to convert this substring to an actual string instead of just having the characters from that substring. And then this just collects it all together, so that instead of having multiple string variables in an array, you just have one long string with all of the separate all of the separate substrings inside the big string, if that makes sense. So that's it for all of this easy all of the easy tasks. The next tasks are going to be the medium tasks. So I believe Minesweeper. Oh, what? Armstrong numbers? Why wasn't I able to do Armstrong numbers? This is easy. Armstrong, okay. We'll do Armstrong numbers. Let me just see what's wrong with Armstrong numbers. We'll see tomorrow when we do Armstrong numbers. We'll do Armstrong numbers, we'll do Minesweeper, and allergies tomorrow. Or we'll do like acronym, Armstrong, acronym, and audio base. Because because I think all the medium goes in alphabetical order, no? N, P, P, yeah, all the medium goes in alphabetical order. So we'll do Armstrong number for easy, and then we'll start doing the medium tasks from acronym and audio base. we'll do Minesweeper when we get down to when we do ISO and nucleotide. But yeah, that's gonna be it for today's coding video. If you like the video, please leave a like on the video. If you dislike the video, please leave a dislike on the video, and comment down any ways you want me to improve the content for your viewing experience, or anything that I can do to improve the content in general. But other than that, enjoy the rest of your day, subscribe to the channel. Peace.